So as I'm going to start this recording here, the topic is called finding quality sources. And for this first homework, and we can look at the phrasing for that, your goal is just to find 3 papers. And that's actually a little harder than it can seem at first glance. Because if I'd asked you to find 300 papers, that's actually a relatively straightforward task. Finding a large quantity of papers is a really easy thing. Search indices are very good these days. You put in certain keywords, you'll get lots of results back out. But I think what's more important is finding papers that can serve as not exactly roadmaps for what you want to do, but as good role models potentially for what you want to do. Although depending on to what extent in your other classes or other projects you've been collecting and reading papers, the first time you do that can be a little bit daunting, a little bit scary if you're not that comfortable with doing it. Search engines exist and they're good, and what I say, in some cases they're considered too good, but they don't really solve the problem of finding what you need. They will respond to keywords you provide them, but you still have to use judgment and some techniques to find what you actually need. And then separate from actually finding a potential input paper to review, you have to have some sort of heuristics to determine if a paper is good or exemplary. And ideally, how to avoid reading 1,000 papers to find 3 useful ones for you should be your goal for this. If you had 2 years, I'd say sure, let's read 1,000 papers together, but you don't, right? So you have a couple weeks. So let's try to kind of slim down the potential candidate list so you can be successful in this idea generation assignment here. I'd be a little careful. I put them in quotes, referring to a paper as good or exemplary. So good is certainly just a subjective opinion. We may not agree whether a paper is good or not. The term I've been trying to use for this particular assignment is exemplary. Um, doesn't necessarily mean that the idea presented in the paper is itself a truly novel one. The other term I use is quality papers, quality sources, papers that can serve as something of a role model for the kind of report that you're eventually going to write. It's a much trickier subjective question as to whether a paper is quote unquote good or not. It may be well written, but the idea itself may not be standing up to the test of time. It's not necessarily our requirement for this particular assignment. There are scholarly search engines that you can use. Have people used any of these before, like Google Scholar or, okay, so you're familiar with them. There are um, many others that one can use. I still like, for me personally, I still use Google Scholar. That's my go-to when I'm interested in doing and looking for a paper. It has some features that just for me, at least, I've gotten used to and I'm familiar with using that service. There is some attempt to link, although it's a little lossy. It's not quite perfect between referenced and cited by papers. So you don't have to kind of manually explore the connections between papers. It's pretty good, as Google has been pretty good at semantic similarity, even if it doesn't quite have the exact keyword you're looking for. It does a reasonably good job of finding things that are reasonably semantically close to what you're looking for. As we look at the Google search output, there's sort of the one-click cite feature where it just generates the citation code for you for your purposes. In my experience, that's a starting point. You almost always have to, it's auto-generated and you almost always have to clean that up yourself so that it actually looks appropriate in your report. And as we talk about finding at least influential papers, citation counts can provide a good shortcut for finding such things. There's other tools. I actually don't know if I opened up any of them here in terms of different search engines and things like that. Yeah, I do have Research Rabbit open, and I think I'm logged in here. This is just another one. Again, there's nothing wrong with Google Scholar, so I can open up Google Scholar as well. Um, but from a given starting point paper, and this would be whatever collection. So let's look at one of this is my own bib entries in here. Um, Reverse engineering controller area network messages using unsupervised machine learning. Perfectly fine paper from 2020. This is kind of a nice tool, and then it attempts to do some of that semantic matching for you. And it doesn't solve the problem of homework number 1, but it does give you a starting point of here's one paper that maybe you thought was interesting. It determines based on its existing index what it considers to be semantically similar papers. It can also do things like what papers did this one reference or what other papers reference this paper. Those are the citations of the paper. And both things can be valid, or papers from the same authors. But in terms of semantically similar papers, you can take that and start to just kind of peruse all of those. Sometimes we look at the title, sometimes we look at the abstract. I think given our relatively modest timeline associated with these efforts, you have to kind of triage the papers you're interested in relatively efficiently. You have to have a method of saying, here's 173, and you cannot read those properly in the time budget we have. To truly read a paper, it takes a couple of days, at least the first few times, and so you don't have that timeline. But can you browse? Can you peruse? Can you get a feel for a paper relatively quickly? That's something you'll get better at, as certainly as you gain more in-depth knowledge about a particular area. But you start with kind of the raw input of here's things that could be relevant to what you want to work on. And this is just based on an existing starting paper, but you can also do it based on keyword search or author search or things of that nature. In this slide, I just give an example of two different Google Scholar searches, similar to what Research Rabbit or other tools would also provide you for the same thing. This is the example I kind of gave in the homework one assignment of you can say you want to work in computer vision or deep learning, and that's fine, but it's not a useful enough descriptor for what you want to work on. So when I type in computer vision, and Google sometimes kind of artificially creates these total result numbers, but it's on the order of several million results. Where do you even start with that? That's a sign your search, your semantic keywords you're looking for aren't sufficiently precise for your purposes. Even when I say something which is, I think, quite a bit more precise of FPGA-based iris recognition, that's a very specific project, a very specific task. Even then, you're going to find a whole bunch of papers to look through. Now, it's sort of a best effort kind of approach here in terms of returning these results. Some of these look relevant. Not all 9,000 of them are relevant. There's a trade-off. Then if you enter something way too specific, maybe you get two results, and that's not good for your purposes either. But you have to kind of balance the generic interest you may have. You can look at survey papers, other high-level papers, but then you have to start to look for something a bit more specific to get some meaningful results from any of these search engines. But I want to give you a couple of techniques that might be helpful to help you winnow down that search as well. When you look at the Google Scholar search result, going back to the prior slide, there's different ways you can sort it. You can sort it based on year, but I think by default there's some combination of year and then citation metric. So under the entry for a particular paper, will be cited by n, some numeric value here. That's the citation metric. That means this paper was published, this is just an arbitrary paper, in 2009. And since 2009, roughly, based on Google's own text scraping and other metadata algorithms, roughly 848 other papers have cited this paper. And actually, in a lot of fields, including most of electrical and computer engineering, that's a pretty impressive number. You get a paper that has citation counts in the hundreds, that counts by most people's perspectives as a highly influential paper. So that is kind of a starting point. So that's the core principle of a citation count, is that the assumption that is when an article is cited, it had an impact on someone else's work. So that doesn't mean a high citation count means a paper is good. It tells us that it influenced other work, is really all it tells us. And likewise, you can't just necessarily sort by citation count and call it a day in terms of finding your impactful, potentially influential papers. Citation counts can be very discipline specific. There's just some topics, some disciplines that just have more researchers than others. And so better is not necessarily good or bad. It just means it's a more popular topic. If you work on a hot topic, you'll get a lot more citations. It also tends to be very publication specific of the type of publications. When someone submits a patent application, in order to get that patent approved, you have to pretty exhaustively show that nobody else has done this idea before. And the way you do that is by including every other possible patent application that even closely touches upon this subject. So if you see a patent application in a Google Scholar result, you'll see thousands and thousands of citations to it. Doesn't mean it's good, interesting, relevant. It just means it was necessary for that publication. Also, when you see a paper published in one of those sort of glossy magazines of prominence, like Science and Nature and things like that, if the venue has one word as the name of it, it's usually a very prestigious kind of thing. Those tend to get thousands of citations as well. Could be very influential papers, but that's just the nature of that particular venue for publication. It can also be very closely related to the age of the publication. Again, that citation count refers to how many other papers cited this particular paper. So, as a matter of just practice, that number is only going to go up. It can actually never go down. So, as a paper gets older, it will by nature get more citations. That doesn't necessarily mean it's influential. Just over time, more and more people found it in their own survey and then decided to include it. And then it also can be very source specific. So Google has its own approaches to determining citation counts. IEEE has its own. ACM has its own. Web of Science has its own. You'll get different numbers, and they don't all agree with each other. It's not a bad starting spot, but it can't be your only approach to determining if something is going to be, um, an appropriate paper for this particular task you have ahead of you. Other things I would want you to look for when looking at these papers and when you get that list of however many you have, um, it's okay to be a little snobbish with regards to this. Again, these are exemplary papers, not papers that you necessarily are going to be able to beat or do better than, but meant to be something of a role model for your own creative component report. So we want something that's done at a reasonable level of quality. You may not yourself reach that level of quality in your own project, but when we aim high and we fall short, the end result's still pretty good. And that's kind of our goal for this sort of thing. So you can be a little snobbish. It's very likely in your field, and we have several different fields represented in this group, it's pretty likely that Stanford is doing better work than, this isn't the real institution, but then Northwest Alaska State University. There may be a really good research group at Northwest Alaska State University. If you find that out, so be it. You can use their papers as much as you want. But when in doubt, you can use the same kind of influence rankings that we use to rank other institutions and departments. And it's a likelihood that it's going to be higher quality work, although not a guarantee. For most of these fields, I think it's important to have relatively recent papers. Some fields that's more important than others. In deep learning, just to pick on a couple of you, if the paper is 5 years old, it's positively ancient, right? It's not irrelevant. It could still have been influential in its time, but you're already starting way behind the rest of the world if that's your starting point for the kind of work you're looking at. So relatively recent papers, that doesn't have to mean 2024, in the last few years in general for this kind of work. Because then the question you'll have in your mind if you pick a 1997 paper is, am I missing something? Is this paper actually touching upon the right aspect of this subject I'm interested in? Or have things progressed since then and it's not going to at all be reflected in this particular paper? Within reason, but the last few years probably is what you want to look for. And then some sort of growing, rising citation count over that period of time. If you find a paper that's 2 years old and has a couple hundreds of citations, it's probably a very hot paper, a very influential paper. Separately, and this is a bit more subjective, um, papers that show some sort of attention to detail in terms of, you should be able to sniff this out relatively quickly as you read more and more papers, but show attention to detail in terms of the quality of writing. Did someone put real effort into this paper? Were the figures clearly put together with care and um, people put hours into this paper and not minutes into this paper? You may not catch that right away, but I'll certainly catch that for you if you don't. Because I think, again, we want to set our standards pretty high, and these papers that show that attention to detail should be a good example for us to follow. And then the last one's a little bit more subtle, and we can certainly talk about that for each of you on an individual basis, but sort of venues that you can trust. I'm a little snobbish about this. For these first three papers, um, I really want you to look for papers that are in those sort of top venues for that particular topic. It depends, and it does change. But for each given research area, which we're still kind of settling on for several of us, but for each given research area, there's going to be a set of top tier conferences. Sometimes as few as 1 to 2, as many as 5, depends on the area. You can't necessarily tell by the name of it, but we can find it. If you're not sure what your top venues are for the area you're interested in, I can help you find those. So you'd want to look at those specifically. And then there'd be 1 or 2, maybe more, depending on the area, top tier journals as well. Those tend to be a little bit more obvious because they tend to have very similar names of ACM transactions on my research area or IEEE transactions on my research area. In general, you find papers that fall into those buckets, you're in pretty good footing for saying that, yeah, this is reasonably likely to be a sufficiently exemplary paper for our purposes here. because I'm going to be a little picky. So if you come back in a couple weeks and the paper is in a fifth tier conference published by no names authors and it's very sloppy, just because it matched your keyword terms, I'm not going to be happy with it. And I'm just going to say, you can put that away, put that in your filing cabinet. You don't have to get rid of the paper, but let's pick some more. Let's pick something else that fits the example a little bit better for what I'm looking for. In our department, in electrical and computer engineering, we generally, whether rightly or wrongly, have something of a rank order of publication impact type. I should note that these slides, this is mostly just my opinion, so this isn't fact, but this is my interpretation of the state of field of research in electrical and computer engineering broadly defined, where our so-called top order publications are those journals of international prominence, glossy journals, the Nature and the Science. That's also area dependent, but some people hope to have one or two papers in those in their career, depending on what area they focus on. Second tier is what we tend to shoot for, and what we really hope for as researchers is those prestigious journal publications of the major societies. That is IEEE transactions on your particular topic. And there's a lot of them now. You should be able to find such a thing. So, and if there isn't, that's a sign maybe your topic isn't really sufficient graduate level topic, but it should be possible for whatever you're picking. That's sort of the second tier, but that's also perfectly valid. Then there's the so-called top tier conference venues of a particular society. You just need to find those for your project area. The names aren't always that obvious what they are, um, but we can find those together if you're not familiar and if you can't find the names of what you're looking for. And then really there's everything after that. There's regional conferences, sort of lower tier journals. There are some fields in which both Springer and Elsevier and a couple other places are actually the top publication venue, but that's the exception, not the standard, not the rule. So there's something wrong with Springer. I publish in Springer all the time, but it's not considered sort of the top prestigious kind of publication in most venues. My preference and my requirement for homework number one is that the three papers we start with come from options 1 through 3, with the caveat that it's very likely to be option 2 or 3 for a given topic. Um, Science publishes scientific papers. They slip through a few deep learning papers every so often, but that's not their primary focus area. So IEEE transactions, ACM transactions, proceedings of the IEEE Society on X, proceedings of the ACM Special Interest Group on XYZ, those are the venues I want you to pick. You should be able to find it. If you come back to me in a couple weeks and say, Professor Zambrino, I can't find any good papers in my topic, that may be the case. Let's re-examine that then together and realize, well, if we can't find anything good, that's the world telling us that this maybe isn't an appropriate topic for your creative component. So that's for the three, though. So for the three, we can be snobbish. So let's find really exemplary venues, publication quality, research, and everything. And then as part of your creative component report, almost always it's going to be sort of chapter 2 of your creative component report. You'll have the related work chapter. It's kind of a formulaic thing. That'll be another lecture we'll have at some point later this semester. There's no rush for it right now. There, you're allowed to be a little bit more broader in terms of what you find. We should be able to find 3 exemplary papers. You may not be able to find 30 in your given field, and that's okay. So then there we kind of loosen our requirements a little bit. And whatever you find is probably okay for your broader related work. Now, in terms of, you found a paper, what do you do next? I don't have my own specific advice for what to do, but if you Google or look at any of those links, there's a lot of advice available for how to read a paper. You can look through those. If you have a paper and you're totally lost, and the answer is not usually start at the first pixel and end at the last pixel. There's other sort of techniques we use to kind of not minimize, but sort of reduce the amount of pure workload associated with reading a paper. In general, my summary of those different approaches is, you have to at least be consistent with what you do when you're looking at papers. You need to organize what you've read. You need to have some journaling system to keep track of what you've read. BibTeX is sort of a file format that's compatible with what we'll be using to compose our reports. That's a perfectly good way to keep track of what you've read. Other people there's a lot of sort of one-off tools like, I actually don't have it downloaded, but Zotero is just an example of a paper organization and categorization system where every time, if you install this software, every time you find a paper, you can right-click on it because it adds an extension to your web browser and allows you to just kind of add it to a database. Whether that's faster than just kind of manually copying and pasting a Google Scholar output, I don't know, but that's another approach one can take. But the big thought there is no matter what, you need to organize it somehow. You need to be aware of what you've read. You don't want to forget papers that you've already tracked down. You need to take notes on what you're reading. That can still be, I think, pencil and paper is perfectly fine for that as well. Electronically, of course, is fine as well. Um, and you know, reasonable summaries of what you're trying to read so that you can remember when you look at it a month, 2 months, 6 months from now. Oh yeah, what was this paper about? Oh, that's right. Here is my brief high-level summary of what the paper is. Also, for this, as well as for this first part of homework number one that people have to get done for next Thursday, you have to set aside some time to actually read parts carefully. Eventually, you'll get better at kind of skimming. Nowadays, when I look at paper, I kind of just skim through the figures and you can get a pretty good feel for what the paper's doing. And you only read deeper when you need to, when you really want to learn something more deeply about a paper. Things I'd want you to focus on for now would be the following things: would be the motivation. We talked about that's part of the homework one assignment is why should anyone care about the project you're working on? Every one of those papers you read will have had to answer that same exact question. It'll likely be in the first section, in the abstract, or in the first section, which is usually called, introduction and motivation. And it's usually one or two paragraphs that you can read because it tends to be written in plain English of why should anyone care about this work. Read it, take note of it, jot it down, because your project may in fact have a similar motivation. You also want to look at the summary of contributions. The novel aspects of the following paper are as follows. That's oftentimes the last paragraph in the introduction. You can oftentimes read that in the abstract as well. Sometimes you'll read the contributions and you'll say, oh, wait, actually, this paper isn't what I thought it was at all. It's doing something totally different than what it sounded like based on the title. Okay, then maybe you can stop reading at that point. You don't have to keep reading the paper. So look at that as well. Um, 2 sentences for the motivation, a sentence or two to summarize their summary of contributions. I personally like to really look at the evaluation section. You read a paper and it seems really cool, and when you want to try it yourself, and then if you look at the evaluation, you may realize, well, this particular paper required a $6 million research lab to do the experiment. That's not for us, at least not at this point in your academic, research careers. So that's okay, but it's good to note that at least that here's what they required to do the work. Not even necessarily a financial thing. It could be how amount of time they had to do the work. Did they have to access proprietary data that we don't have access to? But at least understand what each paper did for its evaluation. I personally care a lot about that. If you have an idea and you want to work on something, that's the question I'm going to keep pestering you about. Okay, but what is that going to mean for you? What are you going to do with regards to this idea? Do you need equipment? Do you need data? What do you actually need? And do we have access to what you need? So let's understand um, what other papers are doing, and we can try to model our work after that. And then, as we're still trying to settle on our ideas and we're looking at these papers, the thought is the relevance of the work may also then influence what you decide to do. So Jack had a few different ideas, and that's great. Maybe as you read a few papers, you may actually settle on one or on something on a fourth idea. That's fine as well. So it's a little bit of a chicken and egg problem that I need you to have an idea to know how to even start with your searching of papers. You can't start from nothing. You have to have a general idea of what you're interested in. But as we look and find these papers, you may get really excited after reading one. And you say, yeah, I actually want to do something similar. And it may spur a spark of creativity. And then you get to choose to work on something like that yourself. And that's kind of the beauty of being in graduate school and working on an MS. Nobody, including me, is going to tell you what you need to work on for this project. And you may not have a lot of those experiences later in life, right? Where no one is telling you what you need to work on next. I'm telling you we have to do something. So I am still telling you have to do something. But within reason, you have the freedom to choose what you want to work on. And so follow your passion and do something that kind of excites you here. So that's all I have in terms of slides on this particular topic. Happy to open up to questions that we have at this point.